Managing air and exhaust, engine performance 1, test 5. What is annealing? Who has ever annealed anything? Have you ever annealed anything? Who knows what annealing is? Who knows? Who can describe it? Who has ever had to anneal anything?
Yes.
It's the heat treating process that takes out the brittle hardening of a cast iron casting. So when something gets brittle and you need to soften it, you're going to anneal it. And it's peculiar how different metals have got different annealing processes. Whenever you anneal steel, you know, you heat it up and cool it off. I mean, let it cool off slow. When you're annealing aluminum, if you got aluminum that's hard, this is really fun. You smoke it up with the torch. Put the torch on the orange flame, smoke it up, and then you put your neutral flame and you play it over there until all of that soot's gone. And then you let it cool by itself and it's soft. Brass, what you got to do to anneal brass is heat it up till it's real hot and they go, stick it in water and it makes it soft. But if you do that with steel, it makes it hard. See what I mean? I mean, it's different for different amount of metal. Technician A says to only use a new exhaust manifold gasket. Technician A says to only use new exhaust manifold gaskets if they were used originally. That's a stupid question. What does that mean? Anybody want to weigh in on that one?
Some of the older vehicles that have manifold gaskets.
Ah, there you go. He figured it out. Some of them had machined surfaces when it was built brand new and they bolted it up. There was no gaskets there. But whenever a thing heats and cools a lot and then you take it apart and the shape changes, you got to put gaskets on there. That's what that can be confused if you're not, if you don't know what you're looking at there. Technician B says to always use a new exhaust manifold gaskets to allow for the slight warpage of the exhaust manifold. And B is right on that one. Which of the following is not correct? A, water will not harm the exhaust system. Is that correct?
False.
B, corrosion forms in the exhaust system in the absence of moisture. Even if it doesn't have any moisture in it, it can still corrode on the inside, right? A small hole at one seam of a muffler means it's damaged and must be replaced. How many of you guys have seen that? Little bitty hole down at the bottom part of the muffler, and there's usually water dripping out of it. Seen that? Little hole, I mean, it's a little tiny hole, about less than 1/8 of an inch, but you'll see water dripping out of it. That hole's in there to let water out of the muffler so it don't rot the muffler, because you're making water whenever your engine runs. I mean, in the wintertime, you see all that steam coming out your pipe. That same water's still there in the summer, but you just don't see it because it's vaporized. So basically, on that particular one, 1 gallon of gasoline produces a gallon of moisture per complete combustion. I mean, during complete combustion. Remember that. I make a gallon of water for every gallon of gas you burn. All the following statements are correct except what? Most mufflers have a larger outlet than inlet. Resonators resemble small mufflers and are used to further quiet exhaust system noise. Mufflers catch the high pressure air pulses from the exhaust system, and most mufflers have a larger inlet than outlet. Why would you have a muffler with a larger inlet than an outlet, and what kind of problem would that cause? What happens if you got your water hose out there and you put your thumb over the end of the hose and you make the outlet smaller than it was, you get pressure. The hose gets tight, right? You don't like that. So you're going to have a larger outlet than inlet. Anytime you got something flowing, if you don't have a larger outlet than inlet, you're going to have pressure build up in there. If you want pressure, that's one thing, but if you don't, it's something else entirely. In an exhaust system, too much back pressure is going to cause you some issues. What sensor is usually located between the air cleaner and the throttle body?
B.
You say B? She said B? Is that what you said? Like Bravo? That's number 5? Is that right?
What was 3 and 4?
What, did you miss those?
Mm-hmm.
Okay, DNA. All of the following statements are correct except what? A, the upper intake is called the plenum. B, the lower upper intake contains long intake runners for low RPM torque. C, the lower intake attaches to the cylinder head. D, a leak from the upper and lower manifolds connect. Where the upper and lower manifolds connect will usually cause a coolant and oil leak as well as a vacuum leak. That's not a correct statement. That last one's not. You understand this thing about why do you need a plenum chamber anyway? A plenum. See that engine on the stand? See that big old aluminum thing up on the top there? Basically, you're wanting to make a pressurized box of air so that every cylinder gets the same amount of air. If you just ran the stuff in there like like headers, you know, you'd have to have a collector and then run it in there. The Escort kind of got that. You know, they kind of like got little pipes going in, but they got a bigger pipe collect. So if you get a good even pressure all the way through this plenum, that means that every cylinder is going to get the same amount of air, and that's what you want. You want to get the same amount of air, EGR, and fuel all the way through. It's pretty good. The only thing that can change from cylinder to cylinder on most of the engines we're fooling with now is ignition timing can be changed on a single cylinder if the knock sensor calls for it. The average gasoline engine uses how many gallons of air for every 1 gallon of gasoline burned at an air-fuel ratio mixture of 14.7 to 1. How many gallons? I said it the other day, remember? How many gallons of air for every gallon of gas? By volume? 9,000. 9,000. And these new diesel engines with these particulate filters on them, whenever they're driving through downtown Los Angeles, the gas that's coming out the exhaust is cleaner than what's going in. In what type of system is the air and fuel combined in the intake manifold? Think about it. Combined in the intake manifold. You know, I could probably pick that one to death, but I'm going to say throttle body injection because you got these throttle plates, those throttle body injectors spraying above the throttle plates. The only problem with that and with a carburetor particularly, well, there's other problems, but fuel fallout. You're going to have a sweaty gas part, on the inside of the manifold, and then when you let off, the pressure drops in the manifold, it turns into vapor, it goes through the engine, and if your air management system's not working right, or you got a, air leak in your exhaust, it'll make it backfire. Pop, 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 pop. You ever heard one stop slowing down doing that? Boop, 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 popping the ass because that gasoline mist goes through the engine, goes into the exhaust, and starts lighting off in there. I used to drive a Volkswagen, when I was a kid, I drove a Volkswagen Karmann Ghia, and it had a megaphone tailpipes on it. And I could switch those car off and switch it back on, and it would look like two shotguns back there. Boom! And if somebody got to follow me too close, if I switched it off and turned it back on, they would just about always back off because they thought they'd been shot at with two shotguns. Just fire coming out of it. But anyway, let's see. Fuel separation with a TBI system can result in
Poor throttle response.
both A and B. You basically want this stuff to get misty. Now your GDI systems, your gasoline direct injection systems, the particles of gasoline that come out of those high pressure injectors in a GDI system are teeny, teeny, tiny little nanoparticles. And you get better flame propagation, more complete combustion, more power. You can actually determine how the fuel is sprayed in as well as when is it sprayed in, instead of just letting the intake valve open and carry it in there. So you can have a stratified charge or a homogeneous charge, and it's just a whole lot more efficient system. There's other problems with it, but as far as the engine itself, you can have a small engine driving a big vehicle because it's got a lot more power. EGR systems do what?
Reduce NOx emissions.
There you go. Reduce NOx emissions is a good answer. And none of those other ones are right because some of them do not have EGR. When's the last time you saw a vehicle that didn't have EGR on it?
Now.
You better say something.
And that van.
That van, you were saying, this van ain't got no EGR on it. And I said, that's right, it don't. It comes without it. If you order an engine, they'll say with or without EGR.
Which van?
The one he's pulling the transmission out of. That's a nasty thing. He's been, he doesn't use foul language, but if he did, he would be using it on that van, I can tell you that right now. A dirty air filter can be reused if it's first blown clean with compressed air.
True.
That's actually, we're not talking about Humvees, buddy. But actually, you can do anything you want to, but the best thing to do is just pop another air filter in it. But I've blown them out. I've thrown them on the floor and then blown them out. It depends on what you got. This one friend of mine that was working on a Mustang that came in there and it wouldn't start. And he worked on it. And he found everything. He had compressions, all this kind of stuff. And then he pulled the air filter out and it was completely clogged up with mud and weighed about 10 pounds.
That'll do it.
It couldn't get any air.
Long as a Mustang full of mud.
He drove it into the drink or something, and then he cleaned it off so Daddy wouldn't know it. But that mud went up in there. It's just funny how that works. But it was, I'm telling you, it was heavy mud. It was 10 pounds of mud on that air filter. But everything else was clean. The understood of the engine was clean. It's the last place you'd think. That's the one place he didn't clean was that dadgum air filter. Then he wound up with a new start. Variable valve timing can be found on which type of engine? All of the above. Cam and block, dual overhead cam, single overhead cam, all of the above. Variable valve timing, and we use it for a bunch of different reasons. You know, EGR is going to recirculate some exhaust gas to combat oxides of nitrogen, but EGR isn't necessary if you've got one that will close the exhaust valves a little early and let some exhaust stay in there, which is what Ford Contours did in 1995, starting in. And then they started using variable valve timing to give it more power by, you know, degree in the camshaft driving down the road. It's a pretty good idea, really. There are problems with it sometimes. To reduce oxides of nitrogen exhaust emissions, which camshaft is varied? Which one did it say? Exhaust camshaft only. You close the valves a little early, leave some exhaust in there. To increase engine performance, which camshaft is varied? Intake camshaft only, right? What's the commanded pulse width of the camshaft phaser that results in desired position? Wait a minute. Let me back up here. There was a different Mustang that these guys were working on over there, and they pulled the heads off, put them back on. It had a, you know, overhead cam time and change, like the one that sort of like a Navigator you did, except it's in a Mustang. And this thing was absolutely astonishing at the power that it had. It would just really run better than even one of those Mustangs ran. But they noticed the fuel trims were 10 plus on one side and 10 minus on the other side, consistently, exactly 10 degrees out of balance, and that was causing some confusion and it had a little bit of a rough idle. And then they found out that he had inadvertently put one of the camshafts one tooth advanced when he put the timing chain back on. And then he was thinking, what if I put the other one tooth advanced? I wonder what that would do, because just one of them, but this thing would really scoot, you know. I mean, it's just funny how you can stumble across stuff like that, make a mistake, you know. But anyway, they put it back like it's supposed to be. Which of the commanded pulse width of the camshaft phaser that results in the desired position? That's a question that would be hard for just about any to answer. 50%, basically. What they're going to, what you need to just put that down there. What sensors are used by the PCM to determine the best position of the camshaft for maximum power and the lowest possible exhaust emissions? What sensors are you? What do you think? What does it need to know? These are the inputs it needs. All of the above: engine speed, crank position, cam position. It needs to know where the crank is. It needs to know where the cam is. It needs to know how fast everything's turning. That's not too hard to figure out. How's the camshaft actuator controlled? Vacuum control, only when conditions are right. Spring loaded to the correct position based on engine speed, or pulse width modulated signal. Yeah, it's got a PWM signal, is what it is. Pulse width modulated. Number 18, if engine oil is not changed regularly, what's the most likely fault that can occur to an engine equipped with a variable valve timing? Who knows? The filter screens on the actuator control valve become clogged. Remember that. You may see that. It's more common than you know. How quickly can rocker arms be switched from low-speed camshaft profile to high-speed camshaft profile on a Honda equipped with a VTEC system? Believe it or not, they can do it in 100 milliseconds. Really something how they do that. Which diagnostic trouble code may be said if there's a problem with the Bank 1 intake cam position? Surely you have those memorized. P0011. That's the P0011. Somebody saw a P0420 this morning, didn't you? P0420 is the exhaust, catalyst efficiency. Variable valve timing is used to do what? We just talked about it a bunch.
Skip 21.
Did I skip 21? Sorry about that. If the incorrect rate of oil, this is a question you asked me, Adam, a couple of days ago. If the incorrect engine oil is used in an engine equipped with a variable displacement engine, what diagnostic trouble code could be set? And that would be A, P0011, that same one, you know, if there's a problem with the cam position. You know, I tell you, if it's got stuff it's doing with the oil other than lubricating, then, you know, like changing valve timing and you use the wrong oil, you're subject to make one run bad. As a matter of fact, if you put the wrong oil on one of those 3 valves like that Navigator, you did those timing change, then you got a crazy running engine. So you got to put the right oil in there. If I pull one in here and it tells me it takes synthetic blend oil and it takes 9 quarts, like that Chrysler Crossfire out there, I'm putting synthetic oil in it and I'm putting 9 quarts in there. I mean, it's 10,000 miles between oil changes, but you ain't gonna say it'd be aight because I'm just pouring some oil in there. You know, if it's something, if that much is at stake, get the oil that's supposed to go in there and let them pay the bill. That's how you do that. And this one girl called me about her Volvo. She said, "What oil did you put in my car?" And I told her we put the, synthetic stuff because that's what it called for. And then I asked her later when I saw her out here, I said, "What did you ask me that for?" She goes, "Well, it looked like I needed to add some." Of course, we knew it was using oil, Let me see.
I don't have the last page of that test.
Huh?
I don't have the last page of the test.
What happened to it?
Cash for God.
All right, just write the answers down.
Somebody eats it.
Just write the answers down, okay? I mean, somewhere, make it numbers and write it down. That's peculiar because I ran them all through the same copy machine, I don't understand how that happens. Let's see, we're on 23,
22.
22. Variable valve timing. What is variable valve timing used for? That's both A and B. You're going to reduce exhaust emissions and engine performance. We've talked about that already. Technician A says superchargers are driven by the engine and crankshaft. Technician B says superchargers use synthetic oil inside the unit. That is C, that's both of them. Superchargers, the crazy way of these superchargers, like you say, the old, like on the old 89 Thunderbirds and Cougars that came out with superchargers on, and some of these other ones. You're looking at this blower that's setting up on top of the motor. All right, do you know how that air travels through that blower? You know which direction it's going? Now, they got an intercooler too, but if you track that thing, the air is going in underneath the blower. It's going out the top. It's going through the intercooler, and then it comes around and goes to the throttle body. So in your mind, you see this thing on top of the engine, you're thinking the air is going through the blower right into the engine, right? But it's not doing that. It goes in underneath the blower, comes out the top, around through the intercooler and back. It's a circuitous route. And that Park Avenue Ultra that the lady from nursing used to have had a supercharger on it, but no intercooler. I mean, yeah, it was supercharged, but it didn't have an intercooler on it. When you heat the air up by compressing it, it's best if you cool it off before you let the engine have it, because it'll cut down on your power. But anyway, it's just remember that. Oh, and by the way, it does have an internal lubricant supply. That's not getting oiled by the engine. It's got oil, and there's a little Allen screw up there that you can see on those superchargers. Most of them that I've seen here lately, or the ones that I'm familiar with. And you take that plug out every 30,000 miles and make sure it's full of oil. That's special oil for the supercharger. And it is driven by the crankshaft. It's not driven by exhaust like a turbocharger is. Technician A says turbochargers send high pressure exhaust gas into the combustion chamber. That's wrong. Technician B says turbochargers use a belt driven by the crankshaft. That's wrong too. They're driven by exhaust. You got a shaft with you got a turbine and impeller on it. The exhaust spins the turbine and the impeller throws the air in there. We have those backwards. Sometimes I get that screwed up in my head. Let's see. The following statements are all correct except A, the turbocharger bearings are usually lubricated with engine oil. That's true. Turbocharger drains power from the engine. That's false. Stop right there. Number 25. B is false. How many internal wheels does a typical turbocharger have? 2. 2 wheels. Remember what I said? The impeller and the turbine. Technician A says the turbocharger turbine and compressor wheels are on the same rotating shaft. That is true. Technician B says it's a good idea to change the engine oil in a turbocharged engine less frequently than in a naturally aspirated engine. That's A. There was the old turbocharged Mustangs and Thunderbirds that they used to have when I was working at Ford dealership over there. I was talking to one of the engineers about it, and I was noticing, I says, when these things were new, whenever the vehicle is new, it seems like it has more power than it does as it gets older. And is there any particular reason for that? And he says, yeah, there's an aging strategy that's built into the engine controller. Because as the engine wears, they don't want you, getting on it too hard, and I'm afraid the engine will tear itself apart. And so what they do is they have it step by step. At the end of its life, it robs about 15 horsepower from you. And he says, now, if somebody's complaining that their turbo doesn't have as much power as it used to have, plug in a fresh engine controller and they'll get that 15 horsepower back. Now, that guy was telling me something that just about nobody knows. turbos, you know. That was pretty interesting stuff, I thought. But that's just the kind of insidious stuff that these people, these programmers, put this stuff in here that automatically does things. There was also, on some of the vehicles that I worked on, an inferred mileage sensor. And what it would do is it would actually have some couple of little contacts here that would ionize gold, and whenever it ionized enough gold over a period of time to where it closed a different circuit, then it would change the strategy on your air management and your EGR automatically. Now, when they were telling us about that in school, the guy that was talking about it says, you're not likely to have somebody that's going to come in at 60,000 miles and say, my EGR is not working the way it used to, and my air management's got 4 minutes of upstream air instead of the old 5. He says, they're not going to notice this. You know what I mean? But the fact that it's there is something you need to understand. And I have had people, I used to notice people would grumble about stuff when they hit about 60,000 miles. They say the truck doesn't run like it used to. It seems like my gas mileage has changed. And I guarantee it had something to do with that inferred mileage sensor. But it would be against the law to disconnect it or whatever, so I didn't ever even tell them what I knew. Let me see here. 28. Which of the following is essential to long turbocharger life? A, keep dirt particles and contamination out of intake and exhaust housings. That's a good one. Flush the turbocharger unit when the engine is overhauled. I would do that too. If it's a diesel, just replace the turbocharger unit usually. When maintain a clean supply of engine oil, and all of these are correct. It's not complicated. Number 29. All of these statements describe oil coking. What is coking? You know what coke is? And I'm not talking about cocaine, and I'm not talking about soda pop.
Coke is isn't it like a product of coal?
Yeah, and it basically, what it is, it's like coal dust. And you can actually have in these diesel engines, you can find the end part, where the EGR flows and all get all coked up, you know, and it's just completely clogged up with that stuff. But I mean, the other things get clogged up with coke too. When the engine is shut down, the turbo has less resistance and will continue to spin without proper lubrication. Coking can be reduced by using engine oil to cool the turbocharger. This happens when the camshaft is starved for oil. Oil flow to the turbocharger stops when the engine stops. That's C. This happens when the camshaft is starved for oil. See, the oil in those particular situations, what we're talking about coke in there, is oil cooks and turns into black carbon stuff. Then it's really nasty. Technician A says superchargers have a delay in their response. Technician B says turbochargers have a delay in their response called turbo lag. That's B only. Superchargers don't have that, but they did away with turbo lag when they came out with the variable geometry turbocharger. Because what they would do is they would open these things wide, open these vanes wide, and whenever you were basically weren't spinning the turbo as fast when you were going down the road, but you were getting more breathing, when you tighten those vanes up and that vane picks up speed, you know, like if you've got, imagine this coming out of there, really exhaust coming out between these vanes are all in a circle, you know, imagine a whole circle with a whole bunch of them like this, comes out of there really fast, spins the turbine quicker, and eliminated the turbo lag because it acts like a small turbocharger whenever it's first starting out. There are also some exhaust back pressure there too, but it's kind of a, you know, give-take thing. So number 30, basically, you're going to put B on that. Atmospheric pressure at sea level is 14 pounds per 14.7 psi, and that equals what? 1 bar. That's why they talk about barometric pressure. Is that what it was? All right. Technician A says a waste gate controls the flow of turbocharged air into the intake manifold. Technician B says a waste gate controls the flow of exhaust gas to turn the turbine. Who's right about that? That's B. Basically, what you're going to do is you're going to open the waste gate and basically fluctuate it to keep you from over boosting. Now there was this funny little story. There was a 88 Saab. I had been working here probably a month, maybe 6 weeks, and this girl from upholstery came over here and she says, I got this 88 Saab that won't start sometimes. And I went over there and I noticed it when I did the ALLDATA thing on it. I found, well, this thing's turbocharged and it's got a pressure switch that shuts off the injectors if it tries to overboost. Keeps it from tearing the engine apart. They want to protect it, you know. And so I went over there and I noticed that there was nothing going to the injector. So I looked at that thing and it said that that thing was behind the fascia. So what the heck are they talking about when they say fascia? That sounds like behind the bumper down there by the headlight somewhere. You know, fascia? But that ain't where it was. On a Saab, the fascia is talking about the kick panel in the car. Well, I found that little white pressure switch with only 2 hoses going to it, and actually not 2 hoses, 1 hose and 2 wires, and it was the injector was getting its power through there, as I remember. And if you bypassed it and shorted it out, the engine would start up. And you could thump on it, and then it would fire up because the contacts in it were oxidized. And I told that girl, I said, I can't order a part for a Saab, and I'm not going to bypass this so you can destroy your engine. So what you need to do is go tell your, she said, well, my boyfriend's got a scan tool, but it won't talk to this. And I said, well, you're not going to talk to a Saab with a scan tool like that. So anyway, I told her, I said, what you need to do is go and get this part and have your boyfriend put it on there, and he'll take care of it. Well, she goes and she takes it home, and Mom says, we're not paying attention to what that guy says because he don't know nothing about a Saab. We're going to take this to the Saab dealership in Montgomery. And they proceeded to do that. And I don't even know who's in charge up there now or if there even is a Saab dealership up there. But $3,000 later, they replaced wire harnesses, engine controller, fuel pump, and it still wasn't starting. And the girl kept telling them, look, all you got to do is replace this little thing, because I showed it to her, and she saw what was going on. And she says, it's right up under the dash there. And they said, no, it's not. It's down there behind the bumper somewhere. You see where I'm going with that? I mean, see how that thing came full circle? But anyway, it was interesting to me that you're going to take it up there. They know well, this is an 88 model, and it's 12 years old, and the people that were up there probably had never seen one like it, in spite of the fact that they were a Saab dealer, right? So anyway, that was a, wow. I call that a Saab story deluxe, you know. Let's see. Which one?
20 or 33.
33. The following statements are all correct except what? Not all air that enters the centrifugal supercharger is forced through the unit. Superchargers may be powered by gears, chains, or shaft. The root supercharger is a positive displacement pump. The supercharger output is the same regardless of engine speed. That would be D. You can take a blower, like on a Detroit diesel blower, and you can set it on the bench, and you can spin that thing real easy, and you can put shop rags on top of it, just a shop rag on top of it, and you can spin that thing with your hand, and that shop rags go. You just blow them off there. And they got these funky big roller things that don't look to me like they pump any air. I mean, you know, shows what I know. I'm not an engineer, but it's a crazy looking deal. And that's the same thing that's in those other superchargers we were talking about earlier. But they're not supposed to touch each other at all. You know, that's why you got to set those helical gears so that they're not touching. They can't make any contact with each other. What did you start to say?
And I said it kind of looks like saw blades in there.
Yeah.
Like a big
Yeah, they're
one.
peculiar. It's like 3 different, I don't know, if you look up at the cross section of them, it's really cool looking. But they're twisted too. They're not just straight like that. But anyway, let's see, which of the following is correct? Wait a minute. Technician A says the pulley on a centrifugal supercharger is larger than the crankshaft. Technician B says the centrifugal superchargers are driven by exhaust gas. That's D, neither one of those right. And finally, number 35, the bypass valve opens in reverse gear. Most manufacturer-equipped superchargers have a bypass valve to control boost. The bypass valve is closed during acceleration, and all of these are correct. Any questions?